Hello, welcome to everyone in this video. In this video, I want to discuss about the solution on thermal physics, CC6 paper in University of Calcutta, BSc Physics Honors. This is the question paper on 2022. You can see this is the total question paper. Question number 1 A B C D E F G H G. Then question number 2 A B C D. Question number 3 A B C. Question number 4 A B C. Question number 5 A B C D. Question number 6 ABC, then question number 7, question number 6 ABCD, and question number 7 ABC. This is the total question paper of this year on thermal physics, BSc Physics Honors. First of all, I request all of you to try solve this question for yourself. This is the question. You try to solve this question yourself. After that, continue the video to watch the solution of this question. First question says distinguish between extensive and intensive variable. Intensive variable means the variables which is independent on mass, that is the amount of material. It does not depend on amount of mass or the amount of material. But extensive variable depends on. For example, pressure, temperature, density, these are the example of intensive variable, and this a mass, volume, area, entropy, internal energy, heat capacity as the example of extensive variable. For example, you have a container with total mass m, pressure p, volume v, temperature t, and if you divide it in 4 parts, then the mass will be m by 4, pressure will be same, volume will be v by 4, temperature will be same. So you can see the property which are remain constant, that is the pressure and temperature. So these are the intensive variable, whereas mass and volume change. So these are the extensive variables. So amount of material, if the property which depends on the amount of material, this is the extensive variable, and which independent, then this is called extensive variable. Independent means intensive variable, dependent means extensive variable. In is the similarity, you can remember. Next question says the mean free path of a gas is 5.0 centimeter, that is the value of lambda, mean free path. Among 100 free path of those molecules, how many are between 4.9 to 5.1? So this is the decay, number decay with distance. Suppose you have a number of any molecule at here is n0. If you travel distance x, the amount of molecules which are within that container is n. This will be decay because their collision will be ejected some particle outward from this container or this region. If you taking a certain volume, so in this region, this with the distance, the amount of molecule will be reduces, right? So n0 is like that, x is 5, the average of between them, dx is their separation, that is 0.2. So if you put within this expression, you can easily find out this amount, that is the how many amounts of molecules between these two region is like that. Next question, using the indicator diagram. Indicator diagram is the diagram between the pressure and volume. In thermodynamics, this is called indicator diagram, which is shown in this below, so that work done is a state function. So if you consider from that point D to B, and if you follow the D, A and B, so the work done for follow the path dB will be the area under this curve, because area under the curve in the PV diagram is denoted by work done. So this is the trapezium. So formula of the area for trapezium is half into parallel sides, sum of parallel side and their perpendicular distance. So dB1 is the P1 and this is P2. So this will be the work done when we follow the path D to B directly. But when we follow the path D, A then B, what will the work done for dA is 0, because there is no change in volume. But the work done for this path, that is AB, is the area under this rectangle, and this is the base into height or the product of two sides, that is P2, and this is V2 minus V1. So you can say this work done from D to B and DAB are the are not same, but also but you can see this initial position and the final position are same. Since this depends on the path, that's why this is not a state function, this is a path function. So work done is a path function. You can say that is it is not a stress function. Work done, you can say work done is a path function because it depends on path on which the process undergoes. So this is a path function. So this is a path function, right? Go to the next question, which says that explain the concept of temperature on the basis of zeroth law of thermodynamics. Zeroth law of thermodynamics says that if two body A and B individually in thermal equilibrium with third body C, that is thermal equilibrium means there is no heat transfer when they are in contact, then it will be called the thermal equilibrium. That is two body, that is A or B individually separately are in thermal equilibrium with another body C, then AB also in thermal equilibrium. And this concept lets you give the concept of temperature, because when A and C are in thermal equilibrium, that means no heat transfer between A and C. That means the property which are conserved between them is known as the temperature. So temperature is a physical quantity which is the same for the system are in thermal equilibrium. So if two body are in thermal equilibrium, which property are the same for these two body? This is the temperature. So in this regarding, from the zeroth law of thermodynamics, we will be obtain the concept of temperature. Next, what is the reason for considering quasi-static process in the context of thermodynamics? In thermodynamics, there is mainly two process, that is a reversible process and irreversible process. For reversible process, there are certain equation and the stable equilibrium equation will be obtained, but in irreversible process there is a problem. So irreversible process, in case of irreversible process, if you want to convert the irreversible process to reversible process in a very small steps, this is called quasi-static process. So quasi-static process is idealized process which involves infinite several small change. This change will be very small such that it follow its initial path. So if you follow this path back to such a way that is it's like a reversible process, but this is actually irreversible process. So brought about the infinite unbalanced potential between the different part of system, between system and environment. So at each step, quasi-static process of the system always every proceeding equilibrium state. So it is necessary to introduce the concept of quasi-static process in thermodynamics, because we are considering three ideal practical thermodynamical system. If our system change abruptly, we would not be able to decide whether we should start our calculation from, right? So that assume the system quasi-static to relieve ourselves on the pen calculating. So irreversible process can be converted into reversible process by this quasi-static process. Next question, so that the Clausius theorem leads to concept of entropy as a state function. So Clausius theorem says if any system K perform a cyclic process constituting of state interact with the series of heat resonators, that is R1, R2 like that, there are with temperature T1, T2, T3 exchange heat of Q1, Q2, Q3. Then the total heat change Q by T is must be less than equals to 0. This is the Clausius theorem. This is equals to 0 for reversible, and for other end this is less than 0. From that point we will be obtain the concept of entropy. For reversible process this is 0, and from initial to final, then and again from initial will be obtained this total is 0. This is a cyclic process, so sum will be like that, and there is the so this is the state function. So from this Clausius statement theorem we will be obtain the concept of temperature entropy. State Gibbs phase rule explained with the example. The Gibbs phase rule says F equals to, that is the degree of freedom, equals C minus P plus 2. C is the component and P is the phase. For example, C is 1 for water component, there is 2 phase, liquid and vapor. If you change the liquid vapor state, there is 2 phases, so the degree of freedom will be 1. So arbitrarily chosen presence one variable of the system will remain in equilibrium. Next question, write down the assumption that he used derivation of Maxwell's speed distribution. For Maxwell speed distribution, the assumption is like that the particles are not interacting, that is no potential energy. If two particles interact, then there is presence of potential, but if there is no interaction, no potential energy present. Particles follow classical mechanism, that is the position and momentum can be defined precisely. If a fixed temperature thermal equilibrium, Maxwell distribution speed remains stable over time. If temperature is constant, Maxwell distribution is the same. If temperature increases, the distribution will be changed. The particles are distinguishable, that is, each particle unique and identical for the. So, this is the Maxwell distribution. Assumption. These are the assumptions. Next question. According to the Maxwell speed distribution law, the number of molecules per unit volume with speed between v and v plus dv is like that. So, this is the number of particles whose velocity lies between v and v plus dv, where the symbol of their calculate the constant a in terms of constant b. So, total number of molecules will be n. So, their summation of this will be like that. This is the triple integration. If we just taking I, so this is IQ, from where we will be obtain I equals to like that, and using the gamma function we will be obtain the value of A in terms of B. Next, so that Maxwell speed distribution law is normalized. So, number of molecule within speed v and v plus dv is like that, nu 4 pi nu square dv. If you consider in the velocity space, that is the velocity v, and if you consider a small change, that is 3v. So, this volume is 4 pi v square dv. So, this is the 4 pi v square dv, right. The probability function will be like that. So, if you integrating, you will be obtain 1 using gamma function. So, you can say Maxwell speed distribution is normalized. Calculate the average x component of velocity in Maxwellian gas. So, this is the x component average, putting this expression, and after obtain you will be obtain this is 0 because this is the odd function. Next, equation of state of non-ideal gas is given by this. So that the equation reduced to ideal gas when V tends to infinity and A and B are very small. So for V tends to infinity, you can see V minus is V and 1 by V tends to 0. So these are the 0. So finally, you will be obtain the ideal gas equation. Whereas if you consider A and B are small, so B moles mean V minus B equals to V and A moles means these are the tends to 0. So this also gives you the ideal gas equation. So for in this in both of these two cases, let's gives you the expression. What is Brownian motion? Brownian motion is that when a particle undergo a continuous motion with external irregular and random, which is independent on the mechanical vibration, that is the shaking of the container. The small the particle size, greater the motion, lower the viscous liquid, greater the motion. So this is the properties of Brownian motion. Obtain the expression for the mean free path of molecule of an ideal gas is a function of molecular diagram. So if you consider this is the molecule which follow this path, which molecule lies between in this path, that its if it sigma is the diameter of the molecule, so this will be the radius of the cylinder. So within that cylinder which come into interact with that one, that is the this count will be this number of atom will be counted in the expression, that is they make collide. So if the diameter of the molecule sigma, then the collide of molecules of cylinder will be like that. This is the area and time t, and c is the distance. So this is the ct bar, and number density, then the number of cylinder will be like that. And for a single collision require 2 number of elements, so divided by 2. Okay, so there is no required of 2 here. So the mean free path will be the number of collision in time t will be like the c bar t. So if you divide it, actually there is a root 2 in the practical. Next, what do you mean by internal energy of a thermodynamic system? Internal energy of a system is like that due to temperature increment is called the internal energy. This is denoted by du equal to Cv dt, that is du is the temperature increment, du is the internal energy, Cv is the specific heat at constant volume. Right, the remutation of the first law. First law of thermodynamics is like that. In first law of thermodynamics, we know dq equals to du plus dw, right? dq equals to du plus dw. That is, when we apply heat within a system, if we apply heat within a system dq, then there is a change in its internal energy, that is enhanced its internal energy, and rest as a external work done, right? So here if we apply heat in a system, then there is a increase of internal energy and rest used as a external work done. But the heat flow, direction of heat flow is not mentioned in the first law of thermodynamics. So direction of heat flow is the not mentioned here, and this not introduce entropy. So these two are main limitation of first law of thermodynamics, that is direction of heat flow is not mentioned here and the entropy not introduced here. Next, what is adiabatic lapse rate? Find its expression for it. Adiabatic lapse rate means the rate at which air temperature decrease at its rise in atmospheres. When we apply, when we rise up upwards, then the temperature will be decreases. So this is the derivation is like that. For adiabatic process, you know the equation of motion, equation of adiabatic process, p v to the power gamma equal to constant. If you replace that is v RT by p whole to the power gamma. So p to the power 1 minus 1 like that. If you take logarithm, then separate out, differentiate in both sides, and for that, if in certain height the temperature is T, if you increase the height dH, then the temperature decreases by dt. So with increasing height, temperature will decreases. So dH is the change is like that. So P equals to H rho g. So dP equals to dH rho g, with the minus is here. When increasing height, the pressure will be decreases. So dP by P is like that. P is RT by P. So these two equation, if you compare these two equations, dP by P is like that and dP by P is like that. If you compare these two equation, you will be obtain this expression, and from here you will be easily find out that is the variation of this temperature with increasing height from the ground. So dt by dH equals to minus gamma minus 1 by this one. Since gamma is greater than 1, so this will be the positive. So dt by dH is negative. That means with increasing height, the temperature will be reduces. In case of for dry air, if you put the value gamma equals to 1.4, mass is 0.029, g equal to 9.8, and this one, so dt by dH equals to minus 9.78 degree centigrade by per kilometer. For if you upward by 1 kilometer, then there is a increase nearly 10 degree centigrade. Actually this is 5 to 6.5 degree. Theoretically this is 10, practically this is 5.65 degree centigrade. Next question is, certain gas has equation of state is like that, P equals to alpha n square T by V square, where P is the pressure, N is the number of mole, V is the volume, T is the temperature, alpha is constant. 1 mole of gas undergo expression from volume V to dV to V, constant temperature T. If the temperature in energy in the isothermal expression is beta alpha T by V, find the value of beta. Given equation of state is like that. For isothermal process, dt equals to 0, change in internal energy du equals to 0, because du equal to Cv dt. You know this formula, du equal to Cv dt. Since dt 0 as isothermal process, hence work done dq equals to du plus dw, du 0, so dq equals to dw, that is the work done is p dv. So if you change from volume v to d to v, put this value expression of p here, so integration will be minus 1 by v. So this is the value of work done, change in. So if you compare these two equation, you will be obtain easily value of beta, that is the half. The perpetual motion mechanic of second kind is impossible to construct, justify the statement. A fictional machine that produced net work in a complete cycle by exchanging heat with only one reservoir is called the perpetual motion of second kind. It violates Kelvin Planck constant, that is, if we take the heat from one reservoir, it does not eject another one. So, this is violate the Kelvin Planck statement, second law of thermodynamics. So, this cannot be possible. Next, starting from second law of thermodynamics, so that the mechanically isolated system at constant temperature, the Helmholtz free energy never increase. Helmholtz free energy F equals to U minus Ts, U is the internal energy, T is the temperature, S is the entropy. So, dF equals to du minus Tds minus S dt. For constant temperature, isothermal process, isolated constant temperature means dt 0. So, this term will be 0, dF equals to du minus Tds. From second law of thermodynamics, Tds, that is first law of thermodynamics, you know dq equals to du plus dw, and second law says that dq equal to tds. So, if you combine these two things, you will be obtain this equation tds equals to du plus dw. So, tds equals to hence df equals to du minus tds, put you will be obtain df equals to minus dw. So, for a mechanically isolated system, dw equals to 0. So, df is less than equals to 0. So, if never increase. So, this is reduce or equals to 0, but never increasing. So, this df cannot be positive. Derive Clausius-Claperoyn equation from the TdS equation. From TdS equation, you know Cp dt minus T del V del T at constant P dP. So, from here you can easily find out, that is ds equals to Cp dt by dt, and like that if you divided by T. So, latent heat L equals to minus Tds, because entropy reduces if you take out latent heat. So, L equals to Cp dt minus this one, because this is Tds. So, this expression is not required actually. From here we will be obtained. So, as temperature constant dt 0, so this gives you like that. So, dp by dt equals to this one. dV is the volume change. So, when a transition from one state to another state, the change in pressure with respect to time will be like that. This is the Clausius-Claperoyn equation. Next, write down the characteristics of second order phase transition in suitable example. No change in internal energy and entropy and volume. Distinguish appear in specific heat at constant pressure and isobaric volume expansion alpha. This condition suggested continuing in the first derivative of Gibbs energy, but discontinuing in the second derivative. For example, paramagnetic to ferromagnetic is the second order phase transition. Next, what is entropy? Entropy is the measurement of disorder in or unpredictability is known as entropy. The expression written as ds equals to dq by T, where T is the temperature, ds is the change in entropy, dq is the heat change. Its property is like that entropy is the thermodynamic variable which is a state function, not a path function, that is, it depends, it does not depend on the path. Entropy is a scalable property, that is the extensive property, that means it's depend on the mass or the amount of mass material that's govern the proportion to the size, that is the scope of the system. Entropy is the universal always expand, entropy of the universe is always expand, and adiabatic thermodynamic system entropy remain constant. Next, entropy of an ideal N, the number of molecules in volume V is given this. So, this is the expression of entropy, where m is the mass of molecule, E is the energy, H is the Planck constant, Kb is the Boltzmann constant. So, that this expression of entropy does not satisfy extensive property of entropy and leads to Gibbs paradox. So, this is the expression of entropy given here. So, you just put for E, this is 3 by 2 Kb T n, this power is same by index rule. We can combine these two things, and finally we will be obtain